This video will be 4 practice problems on exponential growth and decay. I pulled these from a AP Calc test prep book. This should be relevant for both AP Calculus AB and BC, at least as of the filming of this video. Okay, so this is a follow along type of video. I would recommend you pause the video and try the problem first when it comes on screen, and then unpause it to check out how I thought through it and solved it. Okay, number one, if I believe that's plutonium, plutonium-230 has a half-life of 24360 years. Find an equation that represents the amount of plutonium-230 left after time t if the initial mass was n grams. Go ahead and try this one first on your own. Okay, so for this first one, I'm going to explain it a little more slowly, as if you were completely lost and don't remember anything about exponential growth decay. And I'm going to go faster on the subsequent ones. Okay. So we first realized that this is an exponential decay. How do we know that? Well, half-life is continuously halving. So you might have learned this in another class. If it's like, or let's imagine we have 100 grams of something. We have it, that's 50. We half it again, so that's another times half, that is 25. Another times half, that's 12.5. So it's like half to some exponential, to some power. It's an exponential function. Okay? So it's an exponential growth decay type of problem, and this is a decay because it's halving. So it's getting smaller, decaying. Okay? So the general formula for exponential growth decay in general is y equals y0 e to the kt, where y is the final value, y0 is the initial value, k is the growth constant or the decay constant. I just wrote growth constant. T is time. Okay. If you remember the compound interest formula, that when it's continuously compounding, it's PERT, PERT, PE to the RT, where you have the principal, that's the initial value, principal, that's the initial amount you put in the bank. E to the R, that's the interest rate, that's how much it grows, the growth constant. T is time. Exact same model. It is an exponential model, exponential growth specifically. So if you don't remember this formula, but you remember PERT, PE to the RT, again, compound interest formula, or continuously compounding interest, it's the exact same formula, just different letters, different variables. Okay. Now, what did the problem give us? The problem gave us the initial value, n. Initial mass is n. Okay, so y0 is n. We need to find what k is, basically. Okay, we know that it's halving. So technically, you can model this with half to the t instead of e to the kt, because you can always change the exponent into a different base. But I'm going to just use this general model here to explain. So what is half-life? The thing halves. So after, what's the half-life? 24360 years. So after that many years, we started with n. After that many years, n over 2 grams will remain. That's a point. We can plug this into our exponential model. So the final value is n over 2. If we initially started with n, that's y0. And we don't know what k is, we need to solve for that. But t is the amount of years it took to halve, the half-life. And now we can solve for k. Okay, so we divide both sides by n, we get half on the left-hand side, and we take the natural log on both sides. That's what we get here, and then we solve for k. And ln half by properties of logs, because remember ln half is ln1 minus ln2. ln1 is just 0, so it's going to be minus ln2. And it makes sense that it's negative because this is a decay problem, exponential decay, so it should be negative. Okay, therefore, our equation can be written as y equals n e to this k minus ln2 over 24360 times t. This is probably a calculator problem, so you probably need to punch this into your calculator, but this is the exact form, exact solution. I think it's more important to be able to find the exact solution, so it's like this. Okay? All right, so now I'm going to assume we know that model now. Y0 e to the kt. okay? Or CE to the KT if you watched the separation of variables video. Exact same thing, just instead of Y0, it's C. All right. Number 2. There is currently one species in an area of the woods. If 2 years from now, there are 4 different species, how many years would it take to have 100 different species if the number of species is proportional to the rate of the increase? Okay, so hopefully you tried this. How do we know this is the exponential growth model? The key word or phrase, I should say, is number of species is proportional to the rate of increase. Okay? The number of species, if we call that y, is equal proportional to something. So proportionality constant k times what is rate of increase? We write that as derivative, dy dt. And this is exactly the differential equation for exponential growth decay. Okay, so we can just jump to use the model, the equation that we memorize, y equals y0 e to the kt. It's given that our initial value is 1, y0 equals 1, because there's currently one species. Okay, so we can even simplify it to y equals e to the kt, because y0 is 1. Okay, so what's the question asking for? It's asking to solve for t in this equation, 100 e to the kt, because it's asking how many years would it take to have 100 different species. The final value is 100, so y equals 100, 100 e to the kt. We need to find t, but we don't know what k is either, so we got to find k first. And how do we find that? We use this piece of information here. 2 years from now, there are 4 different species. So we are given this point 2, 4, essentially. Okay, so again, we use this model, y equals e to the kt. So our y is 4 species. Time it took is 2. T is 2. So 4 equals e to the 2k. We solve for k. K is ln 4 over 2. Okay, so now we are able to solve this equation that we needed to solve. Okay, so that's what I rewrote over here. And then we solve for t. Well, how do we do that? We natural log both sides and then multiply by 2 over ln 4 on both sides. And this is about 6.644 years. Again, these are typically calculated problems, but this is the exact form, exact solution. This is the approximation. Okay, so hopefully you see the thought process for this. I determined it was exponential growth decay because of the key phrase here. The number of species is proportional to the rate of increase. That was key. Okay, and then they gave us initial value right here, and this is a sample point to help us find our k, and this is the final value that we want. We want to find the t that it took. All right. Number 3, assume the interest in the boy band is growing at a rate proportional to the number of its fans. If the band had 2,000 fans, write the format there, 1 year after they released their first album, and 50,000 fans 5 years after their first album, how many fans did they have the moment the first album was released? So go ahead and try this one. What's the key phrase here to indicate exponential growth? Growing at a rate proportional to the number of its fans. That's the key phrase to tell us it's exponential growth. So we're going to use that general model. Okay. What's the question asking? It's asking for how many fans did they have the moment the first album was released? They're asking for y of 0, or essentially y0. Because when plug in t equals 0, you get y0. Okay. So what information did they provide us? If the band had 2,000 fans 1 year after they released their first album, so 1 comma 2,000 essentially, so 2k fans after 1 year, so 2k fans, that's the y, after t equals 1. And 50,000 fans after 5 years, so 50k fans after 5 years, so 50k, that's our y, t is 5. Okay, what do we need? We need y0. We got to solve this system of equations. It's a non-linear system, so it's a little more difficult, but it's totally doable. Okay, 2 equations, 2 unknowns, system of equations. All right, so it's simplest to rewrite both equations in the form of y0 equals something, set them to each other, and solve for k. So let's go back here. Y0 for this first one would be 2,000 over e to the k. The second one will be 50,000 over e to the 5k. They're both y0, so we set them equal to each other. Okay, that's what happened here. We solve for k. How do we do that? Well, I can multiply both sides by e to the 5k and move this 2,000 to that side, like this. Okay, properties of exponents, this becomes e to the 4k. If we do the math for this, that's 25. Hopefully, you're allowed to calculate, so you don't have to carefully do this quickly in your head. But how do we solve this from here? We natural log both sides, divide by 4 afterward, okay? So we found our k, but we want y0. So we can just plug into either of the original equations to find y0. If you do that, you should get this value, which is 894.427 fans, which is strange, because how could there be a fractional number of fans or a decimal number of fans, right? So maybe you should round down to 894. But clearly, whoever made this problem was just making up numbers. But you can see how it's impossible to have a decimal number of fans. Anyway, okay, number 4. Pretend a dog increased his size by a third every 2 weeks. If he weighs 5 pounds at birth, how many days did it take him to reach 600 pounds? So go ahead and try this one. Gotta be careful with your units. They give this in weeks, but then they're asking in days. Okay, so just gotta be careful for that. Okay, I solved this in 2 different ways. How do we know that this exponential growth decay? Let me go back here. The keyword was increase his size by a third every 2 weeks. So it increased by, or you multiply by 1.333 repeating every 2 weeks. So that's exponential growth. Okay, so we're going to use that general model again. So what information did it give us at birth? Let me change that again over here. So at birth, that's when t equals 0. Our y value is 5. Okay, and it's asking for the the amount of time. Ignore that is asking in days. It's asking generally the time it took for the y to be 600. Okay. So, okay. What was I saying here? Because it's solved in 2 ways. Which way is this one? Okay, so at birth, as I was saying, t equals 0. So that means y0 equals 5. So we can use the model y equals 5e to the kt. So we need to find k. How do we find k? Well, we can think like this. So after 2 weeks, the dog would weigh 5 times 4/3. This is increasing by a third. Increases size by a third every 2 weeks. We multiply by not 1/3 because that'll be smaller, but 1 1/3, which is 4/3. Okay, that's 20 over 3 pounds. We're going to use this point 2 comma 20 over 3 to find k because it's an actual valid point. So this is our y, this is our t. So 20 over 3 is 5e to 2k. We solve for k. I'm going to skip through the algebra. K is ln 4/3 over 2. Okay, we found our k. Now we can find our t. Okay, because this is our model and we want the t when y is 600. We go through the math. I'm going to skip that. You can pause the video to check it out. This is the exact value, or if we put it into calculator and round, it's 33.2823 weeks. Notice I did everything in weeks. Okay, because this is how I set it up in weeks over here on the right-hand side over here. So we just got to convert this week to days. So multiply by 7. That's about 233 days. Okay, so this is one way to approach it. We got the initial value, and then we take a sample point of 2 weeks later. We can do it like that. We don't have to think like this, though. We can solve it a little more generally. Okay, because it is known that when t is 2 weeks, y is 4/3 y0, like we did in the other problem. We don't have to use the actual number of 5. Okay, we can use this relationship to solve for k. We save a few steps, algebraic steps. Okay, so this is the final value. 4/3 y0 equals y0 e to the 2k. And we solve for k here. The y0s will cancel, so you can see we get the exact same thing. Which shouldn't be a surprise as the other problem. We get the exact same thing, and then we can follow the same steps as before. Because we also need to realize, we still need to realize that at birth means t equals 0, so y0 is 5. So we can set this to be a model and then do the exact same thing as before. All right, hopefully for this one, it helped to show thinking about it in two different ways. You can just do that sample point like I did over here, or you can solve it a little more generally like I did here. All right, that's it for these 4 problems. Hopefully this was good practice for you. Please give this video a like if it has helped you in any way, and hopefully see you in another video as well. Bye.